Hello, welcome to Maths with EJD. We continue with probability and joint probability and covariance and correlation. This is actually the completion of correlation and covariance and correlation. So here I'm going to take a worked example to drive home the whole idea of covariance and correlation. So come along. So we have this question. Want to consider a small data set showing the hours studied and exam scores of 5 students. So this idea first came up in the video just before this. So now we want to use the same idea to drive home the point. So imagine we have 5 students, as we said, right? Okay, I guess I want to change now. So we have the student, you have the hours studied. So that's the number of hours they spent studying, and that is our variable X. And then we have exam scores, which we take as exam score, which we take as variable Y. Okay. So this is what we have. So we have the first student, the second, the third, the fourth, and of course, the fifth. So the first student studies for 2 hours and the score was 50. And the second, of course, you can take that as 50 over 100. The second student studies for 3 hours and gets 60. The third student studies for 5 hours and gets 80%, while the fourth student studies for 7 hours and gets 85%. And the fifth student studies for 9 hours and the score is 95%. Okay, so this is what we have now. So the idea is want to calculate the covariance and the correlation for this given data. So let's start with covariance. So one, calculating covariance. That's the first thing we want to do, calculating covariance. Okay. So here we will use the formula I supplied the other time in the previous video, right? We'll use the formula for covariance. And it is simply this: the covariance of x comma y is equal to 1 over n summation from I equals 1 to n. N here is 5 because we have 5 students. And then we have xi minus x bar. That's the mean. And of course, we have yi minus y bar again. That's another mean. Okay. So here we understand that x bar is the mean of x bar. That mean of x, that's the average number of hours studied by the 5 students. Okay. Then we have y bar. Y bar is the mean of y. That's the average exam score by the students. Okay. And then we have n, which is the number of data points. That's simply the number of students we are considering. So that's 5 students, that's 5 data points. Okay. So we go ahead now. So it's clear that we need the average scores. I mean, the average values of random variables x and y. So the random variable x is 2, 3, 4, 2, 3, 4. The values of random variable x are 2, 3, 5, 7, and 9. 2, 3, 5, 7, and 9. So we take the first step now. So okay, I guess I want to change here too. So we go for step 1. Step 1. So compute compute the means of X and Y. Okay, so that means we have X bar, that is 2 plus 3 plus 5 plus 7 plus 9, all divided by 5. Because that is 2 plus 3, 5, 5 plus 5, 10. 10 plus 7 is 17. 17 plus 9 is 16. That's 16 over 5. That is 5 in 16. That is, oh, am I correct? 2 plus 3, 5, 5 plus 5, 10. 10 plus 7. 10 plus 7 is 17. 17 plus 9 is 26. Sorry. That's 26 over 5. So 5 in 26 is 5. Remember 1 over 5. 1 over 5 is 0.2. So X bar is 5.2. Then for Y bar now, for Y bar, we have the values there. That's 50, 60, 80, 85, 95. 50, 60, 50 plus 60 plus 80 plus 85 plus 95, all divided by 5. And then that's 50 plus 60, 110. 110 plus 80, 190. 190 plus 190 plus 85 is 275. 275 plus 95. That's 370, I believe. That's 370 divided by 5. So that is 740 over 10. So that means 74. So that's the average exam score for the students. So that's the first step. As we see that in the formula, right, we need X bar, we need Y bar. So we found them. So the next thing to do is to, so we go for step 2 now. Step 2. So for step 2, we have to compute. We compute the deviations. Compute the deviations from the mean. Deviations from the mean for each xi and yi. Okay. So again, we have our xi values are the values of the x random variables. That's 2, 3, 5, 7, and 9. Okay. Next, we have the yi's. Okay. These are the scores, the exam scores. Okay, we can do this. Okay, so the exam scores now, the first person had 50, you have 60, 80, 85, and 95. Those are the exam scores. Now, don't forget, of course, we've got X bar is 5.2. We've got Y bar to be 74. So we're going to need all that for the deviation. So deviation of each value from the first random variable, that's number of hours studied, will be xi minus x bar. So xi minus x bar, that's simply 2 minus 5.2, that is 2 minus 5.2. So these two here, okay, I guess I want to change markers here for effect. So we have 2 minus 5.2. So that's equal to minus 3.2. Okay, minus 3.2. Okay, I guess I just want to do only the calculations like that. So that is minus 3.2. That's the actual value we are after. Then next we have 3 minus 5.2. That will be minus 2.2. Minus 2.2. Next we have 5 minus 5.2. Okay, and that is simply minus 0.2. Minus 0.2. And then we have 7 minus 5.2. That is simply 7 minus 5.2. That is 1.8. 1.8. And then we have, so for something like this, right, you need to use, it's best to use the calculator that you have mastered, especially if you have so many values. So because it can get really confusing, 9 minus 5.2 is 3.8. So we have the xi minus x bars. So we go ahead again and we have yi minus y bar. Okay. So yi minus y bar. And then we go again. So of course that will be, the average is 74. So we have 50 minus 74. We have next 60 and 50 minus 74, of course. So the next one with 60 minus 74. Next 80 minus 74. Next you have 85 minus 74. Next you have 95 minus 74. And if you do all that, 50 minus 74 is minus 24. 60 minus 74 is minus 14. Then 80 minus 74 is 6. 85 minus 74 is 11. 95 minus 74 is 21. So we have that. So we go ahead, the formula again, don't forget, is like this. So we are going to multiply the two of them. So xi minus x bar multiplied by yi minus y bar. So whatever we get to now sum up everything together, in all the 5, right? So in the next case now, we have the xi minus x bar into yi minus y bar, like this. So what it simply means is that, so each point we have here, again, let me use, so here it means we're going to have minus 3.2 times minus 24. Okay. Then next we're going to have minus 2.2 times minus 14. As this. If you're doing an actual exam, you may have to, well, I mean, maybe it's fine to write this out. You can just write it in something erasable, like in pencil, so that it doesn't overshadow the main thing. And you may even have to leave it on the script to show that you actually know what you're doing, right? So you have minus 2.2 times minus 14. You have it up there. The next you have minus 0.2 times 6. Then you have 1.8 times 11, like that. Then you have 3.8 times 21, 3.8 times 21. And of course, if you do all this, right, minus 3.2 times minus 24 is 76.8. Minus 2.2 times 14 is 30.8. Then minus 0.2 times 6 is minus 1.2. Then 1.8 times 11 is 19.8. 3.8 times 21 is 79.8. So you have all of that. Now, with that settled, then you can actually calculate the covariance of xy. So let's say now that, so we can say, so step 3 now, step 3, compute. So now that you've done the table, compute the covariance. Compute the covariance. And that simply is that covariance of x comma y is equal to 1 over n, summation from I equals 1 to n of xi minus x bar into yi minus y bar. Okay, so that means you're simply just going to have n is 5, right? The data points, you have 1, 2, 3, 4, 5. You have 5 students you're considering. So that means you're going to have 1 over 5 into, so xi minus x bar times y minus y bar. That's all the things you have done here already, this products. So you can just put them together. So you have 76.8 plus 30.8 minus 1.2 plus 19.8 plus 79.8. Okay, so that is 1/5 multiplied by 206. If you do your computation properly, you get 1/5 times 2 times 206. That is equal to 41.2. So that simply tells you that the covariance between x and y is 41.2. So we have that. Now, here we can say that the covariance, between hours studied, and exam scores is 41.2, indicating a positive relationship. This one just tells you the direction, right? So positive relationship. So it means simply that students who study more, tend to score, higher on exams. Of course, that does not mean that there are no outliers. You may have students who do not study as much and get very high scores, but these are just exceptions to the rule, not always the rule. Okay, so we are done with covariance there. Let's go ahead and talk about calculating correlation, which gives even way more information. Okay, let's talk about calculating correlation. So now we have to calculating correlation. Okay, so now let's calculate the Pearson correlation coefficient rule, which normalizes the covariance. So it normalizes the covariance because we divide by the product of the standard deviations, which normalizes the covariance by dividing by the product of the standard deviations of x and y. So the rho, the Pearson correlation coefficient of x, comma y is simply equal to the covariance of xy, which we calculated before to be 41.2, divided by the standard deviation of the random variable x and the standard deviation multiplied by the standard deviation of the random variable y. Okay, as usual, where standard deviation of x and there's sigma x and sigma y are the standard deviations of x and y respectively. Okay, all right, so let's go and do the steps again. So for this now we have step one. So you can see now we already have this covariance, but then we need the standard deviation of x and the standard deviation of y. So the first step is to calculate. Of course, standard deviation is the square root of variance. So we start by calculating the variance, of x and y. Of course, the reason for this is just like I said, sigma x is the square root of the variance of x, while standard y is the square root of the variance of y. Yeah. So calculate the variance of x and y. So let's start with we have the variance of x. Variance of x is 1/5. Or generally speaking, let's just take the variance. That'll be 1/n, summation from I equals 1 to n of xi minus x bar all squared. That's the variance of x. That's the square of the deviations from the mean. Okay, so here that's actually 1/5 because we have 5 students we're dealing with. Okay, into now xi, all the xi minus x bars. So that's all the values here, all these values now. So minus 3.2 minus 2.2 minus 0.2, 1.8, 3.8. Those are the deviations. So we sum up all the deviations and we square the sum. That's what, and we divide by the number of students. So that's minus 2.2 squared. Okay, no, 3.2 is the first. That's minus 3.2 squared plus minus 2.2 squared plus minus 0.2 squared plus 1.8 squared. I mean, we square each term rather and sum together, sorry. Then 3.8 squared. Okay, that's all we get there. So if you expand all this, see the variance of x is 1/5, 1/5 into minus 3.2 squared is 10.24. 2.2 is 2.2 squared, that's 4.84. Minus 0.2 squared is 0.04. Then 1.8 squared, that's 3.24. And lastly, we have 14.44. Okay. And that simply means that we have 1/5 multiplied by everything added together would give us 32.8. And that means that the variance of x is 6.56 if you divide. So you see variance of x is 6.56. So that sigma x itself is the square root of the variance of x, and that is square root of 6.56, and that is simply approximately 2.56. So that's the variance of x. Okay, so we do the same for y. So we say similarly for y, we just have the variance of y equals 1/n, summation from I equals 1 to n of yi minus y bar all squared. So the square of the deviation of each deviation, you sum it all up. So you have 1/5 into, now what are the deviations for y? We have it in the table. So these are the deviations: minus 24, minus 14, 6, 11, and 21. These are the deviations. So we have minus 24 squared plus minus 14 squared plus 6 squared plus 11 squared plus 21 squared. Okay, we square and sum, and then we have 1/5 into each of that. Minus 24 squared is 576, 14 squared is 196, 6 squared is 36, 11 squared is 121, 21 squared is 441. And then we have 1/5 multiplied by, if you add everything together, you should get 1370. And then if you divide that, you have 274. Okay, so that is the variance of y. Okay, that's the variance of y. So the standard deviation of y would simply be the square root of the variance of y. That is square root of 274, which is approximately 16.55. That's another thing we need, right? So with that now, we can take step 2. So we have the variances. So step 2, we can calculate the Pearson correlation coefficient. Pearson correlation coefficient, which is given as rho. Okay. So that's the next one. And what we can do here, we see that that is actually rho of x comma y, which is the same as the covariance of x comma y all over standard deviation of x multiplied by standard deviation of y. Interestingly, we already had the covariance of x comma y. That was the first thing we did. In case we have not done that before, so we have to now go through all these steps. So that's why it's better to calculate the covariance first. So the covariance we got to 41.2. Now we want to standardize it by dividing by the product of the standard deviations. So that's 41.2 divided by 2.56 multiplied by 16.55. The two standard deviations we just obtained 16.55 for variable y and 2.56 for variable x. So now this is approximately 41.2 divided by, when you multiply these two at the denominator, you have 42.38, and that is approximately 0.972. So you can say that the Spearman correlation coefficient of the variable x and y, which are our studied and exam score respectively, 0.972. Now that's a very strong correlation. So what do we say? Say that okay. So what we actually say here is that the correlation between hours between hours studied and exam scores is approximately 0.972, which indicates a very strong linear relationship. So you can see that value is very close to +1. It's almost perfect, in fact. So it's a very strong linear, a very strong positive linear relationship. Okay. So that simply tells us that as students study more, their exam scores increase almost proportionally. Okay. It's very possible that if you get the data from a group of gifted students, the result may not be the same. But on the average, right, we expect this kind of thing. Okay. So in summary, what we've been doing so far, uh, covariance of 41.2 indicates positive linear relationship. It shows positive linear relationship. So it means they either increase together or decrease together. Okay. Then 2, correlation of 0.972 indicates a strong positive relationship with values with values close to 1. With values close to 1. Okay. All right. So we see that these calculations now, these calculations provide insight into the linear dependence between hours studied and exam scores. Okay, so that tells us that as one increases, the other tends to increase as well. Tends to increase as well. Okay, so that brings us to the end of covariance and correlation. It's been such a nice ride. So you want to go over this and practice with other questions so you can actually master it. And if you have not subscribed, of course, you definitely want to subscribe because there's so much to learn here. And don't forget to hit the notification bell so you can always get alerted anytime a new video is released. And not forget to comment, like, and share. I still have a couple of videos on probability, things like the law of large numbers and so on. So until then, bye. Thank you.